So now in step 9, we'll define some instance variables and the means to initialize them in a constructor. So the instance variables are the data that describe what a class is, and in this case they're going to be the user's first and last names. But instead of making them public, we're going to make them private. So private string first name, private string last name. So this class, or every instance of this class, is going to know what its name is. And the reason for making these private is that by good programming practice, we want to protect the instance variables from outside alteration. And then to initialize the values inside the constructor, and again notice we're going to indent by another 4 spaces here, we're going to use this to set up some default values for the first name and the last name. Now notice that this constructor, a constructor is nothing but a special method. It has the same name as the class, and it's typically used to set some reasonable default values for any or all of the instance variables. And remember that a string is just Java's designation for any amount of text within double quotes. So we will once again save these changes, compile them. We've made no errors, and at this point this part of our code should resemble what we see in step 9. So now in step 10, what we'll do is we'll flesh out these methods for which we created the interfaces in the previous step. This print greeting is pretty much the same as last week, so we'll just go ahead and recreate it using system.out.println with a closing semicolon. And again, system.out.println is our standard workhorse print method. So we'll make the same friendly greeting as last time, and we'll piece it together out of smaller strings using the string concatenation operator, the plus sign, space plus last name plus comma space good to have you in class. Okay, and notice the difference between last week's and this week's. This week we don't have to pass any parameters to the print greeting because this method already knows who it is. It already knows the first and last name from these instance variables we defined. And speaking of instance variables, we'll also set up these 2 methods, set first name and set last name. So we'll do first name equals first and last name equals last. Notice that both of these are indented by that consistent 4 spaces. We indent everything inside a pair of braces by some consistent amount, always, no exceptions. And these 2 methods are called mutators. As you might guess, they accept some input string, and all they do is they transfer it to the first name and last name instance variables. So we pass something in, and we're updating these 2 private instance variables. So notice that all of these methods are public. We want the outside world to be able to see and use these. But by contrast, the instance variables are private, and as you might have guessed, these public methods, these mutators, these setters, are the means for updating this private information. So once again, we'll save our changes, do a test compilation, haven't introduced any syntax errors, and at this point our code Looks like we're off by one line number, but that's okay. We pretty much match what we see in step 10. So now in step 11, I did take a look at this, and we actually are a match with what you see in your handout for step 11. And just a few things to point out. Notice that every one of these methods has got a one-line comment in front of it. That's a good programming practice, and I'm going to want you to get in the habit of doing that. And notice one thing that this class doesn't have, and that's a main method. So if we try to run this class, we're going to get a message that says no main methods, applets, or midlets found in the file. This class cannot be run standalone. It doesn't have a main method, but that's okay, because the role in life of this class is to be a reusable component for the main client application. So this class is meant to be used elsewhere. It compiles, and so what we'll do is we will close it and forget about it. So now we're at step 12, and what we'll do is we'll go back to our main method. This is the client application. This is the required main method. And let's finish this one up. So we'll indent that 4 spaces, and we'll add some more code. Create a new So what we'll do here is we will create an object, one specific instance of our hello class. So we'll create a hello object called person, and the way we will create it is we'll do new hello RL, open close parenthesis, closing semicolon to terminate the statement. Then we will print the default greeting. For the default person. And notice that here we are using what's called dot notation. So we'll do person dot print greeting. Okay. And then we will provide the means to update that person or that object. So again, we'll use dot notation using the object. And I'm going to update the value of this object to my own name. And I'll print out the greeting again. So what we're doing here is we're using the hello component that we created and put aside. We're creating a new instance of that hello class, the object person, by using the constructor and the new keyword. Then once we've got this object in existence, we can use all of the things that it provides, all the methods it provides, by using dot notation. So object dot method, object dot method. And here we're printing the greeting based on the default person. Then we're updating the first and last names of the object, and we're going to print the greeting again. Notice that this class is shorter and leaner than before, and that we've buried all of the print details away in the other class, and to get to them all we need to do is make this one single call to print greeting. So finally in step 13 what we'll do is we'll save our changes, compile one last time, and execute. And if all goes well, you should see output that looks like this. This first message corresponds to the print greeting for the default values of the person object, and the second output corresponds to the print greeting after we updated the first and last name of this person object. So in comparing last week's application to this week's, what's different? Well, you probably might have noticed that this main application is somewhat leaner and more efficient than the old one. We've removed the system.out.println entirely from this program and buried it away in the print greeting in the other class. We've now got two classes at work instead of just one. And notice that most of the details, most of the gory details, are buried away in this class. The printing is actually easier because this class already knows who it is by virtue of these instance variables. And this hello class can easily be reused someplace else without change, which is the whole advantage of object-oriented programming. Build it once, then forget about it. It might seem like it's a lot of work to write software this way, but actually writing software classes like this one only represents a one-time investment of effort. Once we've built it and tested it, we can simply put it away and reuse it over and over and over again. And that makes for a long-term savings of effort. If you work in a software organization, chances are you have lots of such components built up available for your use. The Java language provides several thousand of these pre-built components. If you want to do something, it's very likely that that capability has already been created in some existing class. So rather than reinventing the wheel, we can simply leverage somebody else's efforts and get our code working all that much faster. And this is code reuse at its finest. Okay, that ends this demo for Hello Again. Make sure to turn this in and turn in the two files, Hello Again and Hello, both the .java files.